We have three main design concepts for crude oil carriers in operation today. The design of the 70s, of the 80s, and of the 90s. The oil tankers of the 70s and 80s are usually of a single skin construction, where cargo oil is carried up against the hull plating, but in general only with a difference in size of their centre tanks compared to their wing tanks. Also, the longer centre tanks of earlier designs were replaced with an increased number of shorter tanks for safety reasons. The 90s brought a new design of oil tanker with a double bottom and a double skin, which is assumed to be a far safer construction, in particular with respect to incidental pollution and especially in cases of collisions or grounding. The main purpose with the modern design is to avoid oil spills if the outer shell is perforated. Double skin construction will be a requirement for oil tankers built after January 1998, according to new IMO requirements. If sailing to the USA, the double skin feature is a requirement for tankers built in January 1993 or later. In this presentation, we will concentrate on the single skin oil tanker, which remains the most common type of tanker around today. Many of the principles given here are valid also for the double skin design. In general, the traditional arrangement of the single skin very large crude oil carrier, or VLCC for short, is 5 or 6 wing tanks along both sides, with centre tanks in between. In the 70s, one pair of wing tanks was used for segregated ballast. In the 80s, 2 pairs of wing tanks were used for this purpose. Fore and aft ship arrangements are similar for most types of ship, having ballast tanks in fore-peak and aft-peak, and a machinery space and pump room aft. The structural arrangements of a single-skin oil tanker are transverse web frames supporting a longitudinally stiffened deck, sides, bottom, and longitudinal bulkheads. 1 or 2 cross ties fitted between the transverse web frames in the wing tanks. A centre girder fitted in the bottom of the centre tank over the whole length of the cargo area and in the foreship. Oil-tight transverse bulkheads, vertically stiffened and with horizontal stringers. So this is what our oil tanker looks like. How do we most cost-effectively address the issue of hull maintenance in ways to maintain the strength of the hull structure for the lifetime of the ship? Where in this massive labyrinth do we search, and for what?